Hi Pre-Calc. Today we are going to talk about limits and graphs. The first lesson was on limits, looking at tables. Now we're going to look at limits with graphs. So when looking at a graph, the limit exists only when the limits from the left and the right are equal. So this little negative means it's coming from, approaching from the left. This little positive means it's approaching from the right. And some of the ones in the homework only have only ask you what is the limit coming from the left. So you'll see that little negative. And some of them will have the limit just approaching from the right. And if there's no negative or positive, you have to check both directions. The function value at that point is irrelevant in respect to the limit at that point. Okay, so we're going to look at an example here. So basically, if we want to know this limit here, which is what happens as x approaches -1, we have to know what happens as it approaches from the left and what happens as it approaches from the right. So remember with the tables, we looked at if it was like below, like is x, if x was approaching 4, for example, what happened below 4 and approaching 4, and what happened above 4 and approaching 4. It's the same thing here. So this is below -1, so coming from the left, looks like it's approaching -1. What happens as it is approaching, it's 2. We're looking at the y values, We're looking at the y values. So it's going to 2 here, 2. As it is approaching from the right, it is also 2. So because the limit approached the same number coming from the left and the right, the limit at -1 is 2. Okay? So here, it's approaching -4. So we want to know, first of all, what happens as x approaches -4 from the left. X approaches -4 from the left. So this is -4 here, right? This is -4. So as it comes from the left, it looks like it's approaching 3. What happens as x approaches -4 from the right? So as it comes from the right, it looks like it's approaching 4, actually, but it goes all the way up to 4. So in that case, because they are not the same, so this does not exist. Does not exist. Okay? Okay, if we look at this one, as it's approaching -5, as x approaches -5 from the left. So this here is -5. So as it approaches from the left, it looks like it ends up at 2. The y value is 2. And as we approach it from the right, and it doesn't have to be all the way to the right, it's just what's directly to the right. So what's directly to the right is that little piece there, going from -4 to the left. It also ends up at 2, where y is 2. Okay? So because at -5, when we come from the left, it's 2, and comes from the right, it's 2. This is also 2. Okay, so we're going to look at 4. So this is 4. Now here, as x approaches 4 from the left, it looks like y is -3. as x approaches 4 from the right, it looks like y is negative 2. So this does not exist. Jumping to the n, does not exist because they're not coming together. Not coming together at 4. Okay? So the one approached negative 3 from coming from the other side, it approached negative 2. Also, if you see it on the graph, they are not connected together. All right, so 3. So again, if I'm looking at coming from the right, this is 3. I come from the right, and it seems like it ends up at 5, and I come from the left, and it seems to be approaching 5. So the limit is 5. However, what happens if we actually plugged in 3? So it's coming from both sides, it's approaching the same point. It's approaching the same point. So the limit still is 5. However, if you were to plug in 3, notice there's a hole there. There's a hole there. So it does not exist, the actual value there. Just to kind of quick look at another one from this graph, if we were saying x approaching negative 4 from a positive direction, if we were only looking at the positive, because some of them in your homework, they only have the little plus, little minus. Notice there's no limit. You can see there's this arrow that keeps going up. In that case, it does not end at a specific point. It just goes to positive infinity. So when x is negative 4, coming from the right, that graph just keeps going up, up, up. All right, so as it approaches 1, what happens as x approaches the positive 1, but from a negative direction? And what happens as x approaches 1 from a positive direction? So this is 1. So from the negative direction, it seems to approach 2. From the positive direction, y is 1. So they're not the same, so this does not exist. However, if we were going to plug in 1, so if I were going to plug in 1, what is the filled-in value at 1? It's right here. That point is 1, 1. So when x is 1, y is 1. So there's a difference between evaluating the function at a certain point and what the graph approaches. Okay, we're just going to look at a couple more here. So let's say we're x is approaching negative 2. So this comes from both directions, negative 2. So if we're coming from the left, it seems to be like that point where they meet is negative 2, 1. Coming from the right, it seems to also be negative 2, 1. So as x approaches negative 2 from the left, it's equal to 1. As x approaches negative 2 from the right, it's equal to 1. Okay? So the limit is 1. I just want to look at if we were going to actually plug that one in. So if I were going to plug in negative 2, so if we were going to plug in negative 2, notice there's nothing here, there's nothing filled in, so I would be tempted to say it does not exist. However, it is filled in there. So there is a point negative 2, 3. There's a value there, negative 2, 3. So f at negative 2, the value is actually 3. So the limit is 1, but when you plug it in, there's a value there of 3. if we found the value at -4. So if we were to plug in -4, which, let's see, I'll do this in green, this is -4 here. Notice that it approaches from the right, but it never crosses -4. That line just means that it keeps approaching, but it never crosses. So as F approaches -4 from the left, there's no Y value. It just keeps going up and up and up. So this does not exist. Okay, so the limit is positive infinity, but is there an actual point at -4? No, there's no actual point there. So one last slide. Let's look what happens at -4. So we were just saying there's no actual value when we plug in -4, but as far as a limit coming from the positive side, so if we went x as it approaches from the positive side, it seems to be going up, 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 right? Well, that's the total limit. It doesn't matter that there's nothing coming from the left. As the graph approaches -4 from the only direction there is, it goes up. So we can say that is positive infinity. I just want to throw in another one here. That is the limit as x approaches positive infinity. So if you look, as x becomes bigger and bigger and bigger, goes in that direction, what happens to the graph? What's the y value? So it never crosses 0, but you can see this would be like 5 close to 0, 6 close to 0, 7 close to 0, 8 close to 0. The limit is going to be 0. The graph gets closer and closer to 0, but it never goes below 0. So the y, whatever the x value is, the y value gets closer and closer to 0. If we look at -1 here, again, what is the limit as it approaches from the left? It seems to be -1, 0. As it approaches the right, it seems to be -1, 0. So it connects at the y value of 0. Okay? So different ways of looking at limits.